Intro to Embedded Computer Systems Final Project, Jack Ellis and Shaylin Cypher, Team 11, Fall 2025. The design of the final project is that the TI MSPMO G3507 Launchpad is constantly checking for a button interrupt from either push button S1 or push button S2. At the start, there's nothing playing and the screen is blank, but if S1 is pressed, the song, which is an original composed by Shaylin Cypher and the rest of his band, Rivers Cuomo Fan Club, will begin to play. The song is an array of note type structs, which is a custom struct that we created that consists of the three fields, name, frequency, and duration. The name is a string representation of the note. Frequency is, of course, the frequency of the note or the pitch. And the duration is for an unsigned integer that describes how long it should play for as a certain number of milliseconds. So if S1 is pressed, like I said earlier, the song begins to play. The way this is done is a hardware timer A1, begins to go through pulse width modulation. The duty cycle is set to 50%, which represents the volume. So in this case, 50% would mean half volume. And then the period is adjusted to match the frequency of the current song note. A second timer G8, is designed to delay until the note fully plays out. This is where duration comes into play. The period is where the frequency comes into play. During each note's lifespan, the LCD displays the name of the current note playing. So if D4 is playing, then D4 is what shows up on the screen. After every note is played, the array has a counter that advances forward to represent the next note in the song that needs to be played. If we reach the last note, we reset back to 0, and we start with the newest note. Or we start with the first note. If S2 is pressed, we then switch states to stopped. If stopped is the active state, the PWM period of timer A1 is set to 0, meaning that no music is playing. Functionally, that means the song is paused. At this point in time, we leave our counter to be whatever the last number was, so that when S1 is pressed again, we go back to started, where we get to play notes again. And depending on wherever the counter is, we'll play that note. You can see the finite state machine diagram here, where it shows exactly as I described. We start, and then we're in our infinite loop in the main code. If an interrupt happens, we check, is it S2? That means it's paused. If it's not, is it S1? If that's true, it resumes. And if no buttons are pushed, then we're just carrying out whatever the current state is. As this diagram shows, we want to prioritize S2 over S1. So if, for example, both buttons were pressed, then we would want to pause, not resume. The main milestones for this project we split up was the song playing, which represents the array created. The notes are arranged within the array. We've defined the note structure, and then we have a function that can play out a single note based on this note struct. Then we had the finite state machine functionality, which included the interrupts for S1 and S2, the finite state machine itself, checking what the current state is, advancing to the next state based on input, and running whatever our output was, which in this case is the playing note function from the first milestone. And lastly, the LCD screen, just the functionality to make sure that the screen displays the current note being played. For the song, Shaylin completed this. For the finite state machine, this was me, Jack, and Shaylin also took on the LCD screen. So now we can build the project. And if you'll notice here, we get a successful build. And then when we flash the project, we can look over here, give the booster pack some time. I'll pause for now, or actually I won't. So as you can see, the screen is blank until I press S1 and we get our music. And now if I pause, it doesn't play anymore. And if I click S1, it resumes again. And there you go.